Okay, first question, how many people are enjoying the conference? Awesome. Second question, how many people use MailChimp? You guys can leave. Just go. No, just a quick introduction. Blah, blah, blah. The big thing I want to say is I'm a developer advocate with Constant Contact, and so I just want to give a quick shout out to them because they paid for my flight to be here, which is great because otherwise I've been a really long walk. And it's cold. I moved from Minnesota to San Francisco to avoid this winter stuff, and they're like, let's fly you out to Utah. 25 degrees. So I really want to thank them. If you like the presentation, please afterwards shoot them a tweet, say, hey, thank you. If you didn't like the presentation, I will bribe you to tweet them and say thank you. I actually won't. I can't afford it. So what we're going to talk about today are traits. And a couple people here have used traits already. We're going to kind of look at the overall, what they are, how to use them, some good examples to use them in, and some bad examples. So we're going to kind of look at this whole concept of horizontal design or code reuse, horizontal reuse. We're going to then take a look at an application I built, first using traits. And then I said, hey, this doesn't work in PHP 5.3. This sucks. I'm going to use classes and extend classes. And how much worse can it be, right? So we'll look at that. We're going to look at some of the benefits, some of the challenges, and then kind of how it works within the world of PHP. So first and foremost, I always like to be super technical in my talks. What are traits? Traits are a mechanism for code reuse in a single inheritance languages such as PHP. I know, that's so awesome. I like that line right there, like single inheritance. The best way to think of traits, instead of trying to take this technical, I don't know, maybe I'm just stupid, I can't understand it, is think of yourselves. How many people here have eyes?
How many people have ears?
Who fell asleep already? I haven't even started. If you have eyes, maybe you have ears, maybe you have arms, maybe your eyes are brown, maybe your eyes are blue. So as we look at traits, let's not just think of it as this fine-grained and consistent way to integrate new code and modify your classes, but think of it as you're modifying the overall behavior, just like traits would. So just like you have blue eyes, that's part of your DNA makeup, that they're blue. If you have brown hair, that's part of your DNA makeup. And what we're doing with traits is we're taking a class, we're taking this body, and we're saying, hey, by the way, we're going to modify this. We're going to add this. And instead of having to extend class after class after class, we're going to do it in a horizontal platform. And what's important with traits is it's the combination of the traits working with the classes. If you try to use a trait by itself, it's not going to work. That's kind of like trying to see with an eye without using the brain. So in the same way with PHP, traits are collections of methods that can be imported into classes. Also, a really cool thing with PHP and traits is you can import properties. That's something you cannot do in most languages with traits. They each stand alone, but once pulled in, it becomes part of the class that you're calling. And it really becomes a seamless way to integrate. Traits are designed very specifically for code reusability and extendability. How many people have started coding and you extend a class and it's awesome, and you extend a class and it's awesome, and you extend a class and it's awesome, and you extend a class and you realize at the very top of the chain something doesn't work with this class and now you have to start over? Nobody? Okay, thank you. That's what we want to fix with traits. We want to be able to say, I don't want to have all these issues where all of a sudden I have this base class that's no longer compatible with all my child classes. So a quick look at the trait, it's very, very easy to do. We simply call a trait just like we would define a class, trait, my trait. We put our method in there, and then this is super awesome. You guys ready for this? Like, this is my entire presentation right here. By just putting use my trait within the class, that class now contains that test method. We've just taken a new method outside of our class and imported it, and we didn't have to use RunKit. Big plus. So the concept between horizontal design or horizontal reuse is simple. We want to reduce duplicate code. Who likes writing duplicate code? Yeah, there's like, no. It's always that fun time when you have to change something. Or maybe you're writing classes and you have to have duplicate code for the different classes to accomplish something. And then it gets a little bit more out there. I'm pretty sure it's like 3, 4, 5 different classes. And then your boss says, change it. We don't want to do that. So That's the whole purpose of traits. In traditional vertical design, again, you have your interface, you have your abstract, your parent class, your child class, and this is great except for that's what you're limited to. You're limited to the capabilities of your parent class, your abstract, your interface to a degree. Because this is limiting, we have seen things such as dependency injection. Dependency injection is a great thing unless you use Zen Framework 2 in its beta stages and you create the 3 different abstract classes to import a single class. Now they have the service locator, which is great because I hated myself during that time. But the problem is, just like anything else, people got dependency injection said, oh, well, I can inject this, and then I can inject this, and then I can inject this, and pretty soon we have these super bloated classes that are just using all this processing power to run. And so traits allow us not to get rid of dependency injection, but to use it properly. And to not have to call in classes just to call them in and have them readily accessible, but to have them available via the trait. So what this allows us to do now is we have our interface, just like we did before. We have our abstract class, just like we did before. We have our parent class. But we want to make some modifications to our parent class, so we add traits and pull them in as we need them. Same thing with our child class. We have traits down there. And here's where the magic happens. What do you think we can do with this setup right here? Well, if we look, we can say, okay, we're going to create trait, trait 1, trait, trait 2. And you'll notice that these have different methods. The first method is method A, which is in trait 1. The second one is method B, which is in trait 2. So we say, hey, this is my class. Use trait 1, use trait 2. We'll instantiate the class. And then we're going to go class method B. So now we have an issue, because if we go to trait 2, where method B is, there is no method A, right? So what's going to happen? It's like Jeopardy. Any ideas? What will happen? Well, the great news is, because traits get pulled in horizontally and seamlessly, trait A, or method A, now exists in my class. So even though it's not part of the trait, not part of the class, it's still getting called in. So this A will then run this, which will echo trait 1 method. So this is what traits allow us to do. Traits will work together with other traits. They'll work together with the class. They became seamless. And so pretty soon we have this huge conglomerate of what we can do. You know, we can have information going this way. We have information going this way, this way, this way, this way, this way, this way. I feel like a salesman. And you can do this with it, and you can do that. And he's going, and you can shut up. Traits can also be used in a vertical manner. We have, again, trait 1, trait 2, and then we have our parent class. And then we have our my class. So in our parent class, we're using trait 1. In our my class, we're going to use trait 2. So we go this method A, go to trait 2, because this is going to be our child class's new method. And it says use parent A. Jumps up to the parent where this trait has been injected. It says use method A, trait 1 method. So you can actually even separate the traits based on that level. So we have a trait that's assigned to the parent class, which only affects the parent class. And then we have a trait that's assigned to the child class that affects, well, both of them because of the extension. Voila. I've been practicing that. I was told I could do that very well, and apparently I couldn't. Do you guys kind of see what you can start to do with traits? Are there questions so far on how they work? Yes? Yes and no. You know, it's one of those fun things where it's like extended class, extended class, extended class. To a degree, it's a good thing that allows for nice, easy-to-read code, and allows for extendability, allows you to do things. Now, if you just start doing traits for traits' sake, and you have 10,000 traits attached, no, it's a horrible idea. So we're going to kind of talk about that. With traits, traits are like anything else. You can use them for good things, or you can use them for evil. And we all know the motto is don't be evil, unless it's a Friday, in which case it's okay. Good question. Any other questions? Yes?
How do you manage the dependency of traits where one trait's calling another trait and needs that trait? If you don't include it, then you're going to end up with a bunch of error. And in a model like this, it's almost like every trait needs to include every other trait in order for dependency.
Well, and the way this works, that's a great question. We're going to talk about some of the dependency issues that we run into and how to address those. But the way this works is basically you've created a giant class. So you basically, instead of thinking as trait, class, what you really have is you have this class, which now incorporates these child methods. And then you have this class, which incorporates these methods, and they become seamless and work together. So you still, code-wise, still have your parent class and your child class. It's just that because these have become in part of this class, they have access to it just like you were extending it. So when we talk about dependencies, there are things you can do, but it comes in how you write code. If you're calling in a trait that has another requirement and it's not being met, that's actually be a coding issue. For example, let's say you're using traits to build a pizza, and you call in sauces, and sauces requires on the measure trait being there, but the measure trait's not there, then it'd be the same issue you'd run into as if you were doing extending classes and you forgot to include the measure class as a parent class to the sauce class. The difference is this gives you more extensibility so that you can call in sauces, but then also call in meats or vegetables and kind of bring in more than just a single class at a time, and also eliminate some of those dependencies that you run into that get you boxed into a corner. So again, they work seamlessly together with encapsulation. So if you look over here, we have trait1 method. This one then is going to call the A method, parent class. My class extends parent class, use trait2. Because it's using trait2, trait2 pops up to a parent class which uses trait1, grabs it. And you can see kind of how this works with that process. We could also do the same thing where in this one we did parent. Again, it becomes a seamless, just like you were extending the classes, the code becomes part of the class. Again, just to think, if you think of the body, think of DNA. Once you say they have blue eyes, it becomes part of the DNA as a whole. You really can't separate at that point. So it seems like really convoluted mess at this point. We're looking at this going, okay, all this is going on. How do we fix this? No worries. What we're going to do is we're going to look at this application. And this was a simple application I built because I wanted to do responsive design and then also server-side stuff. And I really didn't want to spend a lot of time back and forth saying, okay, this is a TV, this is a mobile phone, this is a laptop. So I wanted to create just a quick, easy application to handle that. And it's a very simple application. There's just 5 files. And so if we look at, first I built it horizontally using traits. And it uses really the same 5 files, but in this case we have a base for validators, a base for extenders. And all that is in this one is I wanted to create so that you could have your base functions, and then wanted to create a plugin so that the user could modify the plugin without having to override the base. And then building a vertical app, kind of doing the same thing, but we have to do a different process. Now we're going to call in them as namespaces to have them as classes available to us. And now we get to the construct. Horizontal app, this is our awesome construct method. I'm saying, hey, grab the base tags, grab this tags, because again, these are traits. And because they're traits, their properties automatically become part of this class. So I have to go back and try to figure out which is which. They're automatically there. Same thing for the extenders. Grab the base extenders property, grab the extenders property, each from their own respective trait, automatically, seamlessly in the class. Very easy to use. And by the way, these slides will be available online. The code is also available online, so you guys can look at this later as well. So the vertical app, however, took me a little bit more work to get to the same process. Because now instead of having traits that get pulled in seamlessly and having my properties available seamlessly, I have to instantiate classes to access these things. So I have my extenders class, which I also, again, the dependency injection. This is really not a good use of dependency injection when we have traits available to us. Because I'm basically saying, hey, I have this object's dependent on you, so here's this object, so you can do things to this object and send it back to the object. Thank you. That's not a good flow. Then we have to do our array merge, base tags, validator tags, this extender class, base tags, this extender class, extenders. And heaven forbid that these are private variables, because then we don't have access to them, and the world just blew up. So as we keep doing this, we have to extend it, this RSF, for trying to get to this. again, because we're passing across the dependency injection, and we're saying, hey, this, our stuff comes in, keep this, so we can actually modify and update that as we're doing things. And what we've done is we've created this huge cycle of going back and forth between two different objects, and we're going to be using a lot of processing, a lot of memory. It's going to be a lot of fun. Of course, we also want to have a GetView, SetView, do it the right way, so our getter and setters, so we can set these variables because they are private, and I can't access them through the main object class, even though I'm trying to modify the main object class. You guys with me so far? This is not confusing at all, right? It should be, because this is a horrible way of coding something. So with the horizontal app, again, because we have everything already here, we can do just a very quick this view, grab the matches, and all we're doing here is we're just looking for a short tag, RSF, grab the actual function, then we'll run the function for the item. You know, replace, set, call, very nice, compact, simple to do, because again, everything's accessible in this class. Another way to think of it is, I have these 3 markers. Now these markers, I normally don't have. Like I don't walk around with 3 markers. But these are my traits. So right now they're in my hand, and I have them. But if I do it the old-fashioned way, I'm going to give you one right there, give you one, give you one. Now if I want one of the blue markers, I have to walk over here and say, hey, can I borrow that blue marker really quick? Thank you, that's awesome, but I can't hold on to it because that's your marker. I'm going to grab the black marker here. Can I have the black marker? Perfect, thank you, but I can't keep this because this is yours. And this is what we're doing the old-fashioned way through dependency injection. Versus me just saying, I'll just take this and include it, I'll just take this and include it, and I'll just take this and include it. Nice hat, by the way. But, you know, it's like, done. That's what traits do for us. They make it much simpler. So going back to horizontal app, or stay with the horizontal app, we also can do, you know, caching. We have our extender, our cache. Again, everything is so easily accessible. It's right there. We don't have to worry about jumping back and forth. The vertical app, not so much. We're kind of doing the same thing, except for we have to get each one from the getExtenders class, run through that. Again, we're using another object, going through a whole other leg just to get these items. And then we're doing the same thing here. We have to go get base, get extenders, get the cache, get this, get this. Again, I'm asking these guys for these markers, and I can't hold on to them because I have to give it back. And it's really taking a lot more time. So here was the end result. Using traits versus using the original dependency injection design. Doing dependency injection only, I had to add 195 lines. I had 39 deletions. Now, my math teacher would be very proud of me because I figured out that's a bad thing. I don't know the exact number. I'm not that smart. But this is a very simple application. We're talking an application that has 5 files, 454 lines of code. Very, very basic. And yet by using traits, not only was it more efficient, not only did it run faster, but I reduced the code by 34% and reduced a lot of duplicate code that I had, excuse me, that I had in my other classes. This is what traits allow us to do. Now, don't worry, this was not a, hey, here's traits, learn them, good to go. Everybody knows how to use them now, right? No. Again, it's really to show us the advantage of why we can use traits. The benefits, reduces the amount of code needed. Reduces dependency injection requirements, which dependency injection is great. You go to ZF2, it's everywhere. It's awesome, but it does use memory and processing power. Provides seamless integrations of classes. Code can be used by multiple classes. You know, hey, we're making a pizza, and I want to use that sauce trait and that measuring trait, but maybe I'm also making pasta. I can still use that sauce trait and that measuring trait versus having to extend. They're right there, and I can reuse them very easily. The other problem with all that extension is if I'm doing an extension of these things, I cannot make them different. Once I have an extension of a class, if I want to use that same process, I'm already extending a child class of that to get that, which creates a problem, and that's what gets us boxed into that corner where eventually hit a point where, like, crap, I can't continue without going back and doing a major rewrite or modifying the base class that this all extends. It also allows for multiple interactions and eliminates vertical asphyxiation. I think I asphyxiated a little bit trying to say that. Or dead ends. It's plug and play friendly. You want to add another trait to the object? Done. very simple to do. And you can keep adding traits. So you could actually have 10 different traits assigned to a single object. Again, be smart about it. Don't set yourself in a situation where you're going to have code flying all over the place and you can't figure it out. One thing you can do that we'll talk about later regarding your unit test, however, is you can use the reflection class to figure out what traits are doing what. So there is some other tools we can use to figure this out. And there's no class name conflicts as you have with namespaces. The challenges, however, are there property conflicts. Properties and traits in calling classes must be exactly the same. And when I say exactly the same, I mean the triple equals exactly the same. They must have the same value and be of the same type. You can run into method conflicts and overrides. If you have a trait that contains multiple methods and another trait contains the same methods, and you throw them together, PHP doesn't like that unless you declare which ones you want to use, and it blows up with a fatal error. It can be harder to navigate code. How many people remember your first time working with an MVC framework? And your boss said, there's a bug, go find it. Yeah. So it's the kind of same thing with this. It can be hard to find the code as you have to look around for it. And it is limited to PHP 5.4 plus. The great news is 5.5 is out there. The bad news is most people are still upgrading to 5.3. So technology always lags a little bit behind. So the difference between classes, abstracts, and interfaces. Traits are very similar to abstract classes, except that they cannot be instantiated by themselves. Like the abstract classes, they cannot be instantiated by themselves. However, the difference is abstract classes are extendable, whereas traits are not. Traits are basically one and done. It's a horizontal use, not a whole vertical chain on top of a horizontal chain, because then you just have boxes flying all over the place, and they wouldn't fit on the slides. So I begged them not to do that. You can use traits within other traits, just as you would in a class, however. So you can actually have more horizontal traits within the trait. Like you're keeping that horizontal design going. You're not designing vertically within a trait. And traits, again, can contain methods and properties. One of the nice things about PHP, but it's also one of the things that if you do, you have to be very careful with because it can get you in the end. Trait hierarchy and class overrides. Because traits are applied horizontally, there is not a vertical hierarchy. When you extend a parent class and you have a child class, the child class overrides the parent class. When you take a trait and you put another trait in there, they're the same. They're the same with the class. Again, if you have two methods that are exactly named in these traits, they're going to have a problem. You're going to have a failure being thrown. If a class has an identically named method, it will override the trait method. So if you throw in the trait and the class has the same method, it's going to go with the class method initially. Now, if the class parent has a method named identically to the trait method, guess what happens? Yep, the trait overrides the parent class method unless you call the parent explicitly. So you guys are getting this. This is awesome. So since the class contains the same method as the trait here, as you can see, we have my trait function test, my class function test. We call my class test. It's going to echo out class Y because the class will override the trait. There is a way to specify that you want the trait or to alias the trait so you have access to that method as well. We'll talk about that in just a second. Again, if it's in the parent class, the trait will override it. If you want to access it, make sure you're using the parent call. Otherwise, you will not have access to the parent method, just as if you had extended and overridden a parent method with a child method. Again, the same flow follows. Trait aliasing. If you run into two traits where they use the same name on the method, or to make a trait method available within a class, we can alias the trait using the as and instead of keywords. The as keyword will give the method an alias to reference it by. Now, the original method name will still be available if you just rename it, but you can use as to say, if you have two named test2, and then call test2 for what you're trying to do within the class. The instead of keyword tells the compiler that you want to use a specific trait method over a different trait method. So in this case, we have trait 1, which has a method test. In this case, we have trait 2, which has a method test. And we pull those both in our class. And just like you would with namespaces, you can put commas between them and call them in. And so we say trait 2 test instead of trait 1. And then we say trait 1 test as 1. Why are we doing the second line? Yep, this way we have access to the method in trait 1 still. Because what we've just told PHP is, hey, whenever I call test, I'm calling trait 2, not trait 1. So if we do 1, we're going to go to the alias test in trait 1. If we do test, however, we'll go to 2. When using multiple declarations in your class, it's important to place the instead of declaration before the as declaration to avoid conflicts. Does not really work if you go the other way around. So it's just instead of and then use as afterwards. Otherwise, if you're putting an alias, it may not know which one it's supposed to use, blow up, or you'll have very unexpected results and you won't be very happy. Using multiple use statements. So this is one of these things about coding standards. You can do this, but really the only reason you should be using multiple use statements in that conjunction is if you have multiple use statements you need to call in and you're trying to segment them to say, okay, this is for this action, this is for this action. And then you should have comments saying, this is why I'm doing this. Because otherwise people are going to look at this and go, why? Point in case is you can do it this way. You can say, hey, I use trait 1, use trait 2, define those. Use trait 3, trait 4, define those. Or you could just use trait 1, trait 2, trait 3, trait 4, throw this code up there, and do the exact same thing. But if you want to get fancy, something you can do. You can also modify the visibility of states through the use declaration. Again, one of the really cool things about traits is chances are when you're pulling in a trait, you want this code to be reusable, but you may not want the public visibility state to be the same in every case. You may want it to be private in one class or public in another. This allows you to say, hey, grab this method, but make it protected. So it gives you the chance to really define and restrict things so that you can meet the needs of the individual class. If you have a class that's being used by developers where, like, hey, I don't want them calling this method outside this class, protect it. If you don't want them calling this method outside of this class at all, you can mark it as private. It gives you a lot of power to really try to customize the trait as much as you want to meet your needs in its use case. Also, oftentimes a trait method may require interaction with a class method. To do this, you can create an abstract method in the trait. You ask, hey, what if I am pulling all these traits and there's no method for this? And I try calling it and it doesn't work. What can I do? Well, by throwing this public abstract function do something, if in our class we don't have the do something method, we're going to get a fatal error because you cannot call an abstract function from a trait. So that's one thing you can do to say, okay, these are the functions that are required. Just like you would in an interface, or you say, okay, interface, we need this, this, this. You can do a similar thing without the parameters with traits to say, these are the methods that are required for this trait to function. And then once you hit that dead point, throw a fatal error, alert you that something's going wrong so you can get taken care of. Questions so far on any of that? Trait properties. Again, this is really cool with PHP is you can have trait properties in your traits, which means that let's say you have a class where you're going to need properties that you want to bring in over and you want the properties to be the same across the line. You have the same code, one single place, easy place to update, pull them into the class, awesome. The problem is if you have a property with the same name that has a different type or different value, it will blow up. Now you can have the same property in both. And as long as it's the same type, same value, it says, hey, this is great. The problem they ran into when looking at properties where they were like, well, if it's really horizontal, which overrides which? Do we do classes which override the trait? Do we do trait that overrides the class? And it basically came, this is kind of confusing. Let's just not allow them to do it at all. So properties have to be the same and identical. Example here, we have trait, my trait, and my class, and they both have this property called test. And test is a string, and it equals high in both cases. What do you think is going to happen? Why is it going to blow up? Just ignore the text at the top, by the way. Yeah, one's public, one's protected. The visibility state is different. Therefore, this is not allowed. It will blow up. It will not allow this, and it will throw a fatal error. In this case, we have the same thing. They're public. They're both called test. They're both a string, but the value here is high value is by, not going to happen. PHP is going to say by, fatal error, not going to do this. They're not the same. They have to be exactly the same in state, type, and value. In this case, this would work just fine. Questions on using properties and traits? Yes, sir.
Generally, you just want to not have the properties in the class.
Yeah, then that's kind of the reason that it came up in the RFC where they're like, do we even allow this to be different? Is they said, look, if they're different, they're probably not trying to do the same thing. So yeah, if you're putting properties and traits, chances are these are properties that you want standard across anywhere that trait is called in, and so you won't want it in the class. So that'd be the best practice there, or preferably not to put the property in the trait at all and have the traits or the properties in your classes only. That takes away from the usability or reusability aspect just a little bit, though. Again, the big issue is, and the big concern was, if they're not the same, maybe you're using that property somewhere else in the class to do something different, and that's why it would blow up. So that's why the fatal error. Trait functions. One nice thing about traits is there are multiple functions that you can use. There's trait exists, which is similar to class exists. You can see if it's available, if it's been defined, and then of course it will return a Boolean saying yes, it's true or false, it exists. Get declared traits, similar to get declared classes. It will get you a list of all traits that have been declared. Get traits will return an array of all traits used in a class, while get trait names will return an array of all the trait names used in a class. Basically, if you alias a trait, you can change the name, so that's what we get. Get trait aliases returns an array of aliases linked to its original trait and method. So if you're trying to say, okay, I put this one there, put that one there, it'll bring that back. And then isTrait is just a Boolean that says, hey, return whether or not the tested object is a trait. So if you have a class that you're trying to say, is this a class? Is this a trait? These functions are very similar to the PHP functions for testing classes. Identical in pretty much every manner except for what they actually do. So, any questions on anything so far? And the big thing with traits, I mean, the best way to learn, honestly, is to take this stuff and then put it in practice, to try it out, see how it works, see what you can do, play with it, make sure it fits the needs of what you're trying to do. So some more use cases. Somebody asked me, like, well, what would be a good case to use traits? What would be bad cases to use traits? Well, I want to do an API controller. And I want to do an API controller because this morning's session was on APIs, and I used the ZF2 abstract RESTful controller, and I pull that in as an extension, but maybe I want to do more with that. Maybe I don't want to just have that one class and then block myself off. So here we have this setup. Well, what happens if we need to modify the controller? What happens if we need to change something here? What about compatibility here? What if API controller needs new dependencies because the application was updated? And we're already extending that. How do we update these things? How do we make these things work? How do we avoid that box of doom, or what I call vertical asphyxiation? Well, what we can do is simply call in the API controller as a horizontal and add these API methods to our existing controller. What this does is this keeps us clear of this vertical line of death where if we need to extend it, we can. If we need to make changes, we can make changes and then just say in the class, I want to override, do what I need to do with that. And if we need to make changes to the modified controller, we have easy access to do that without worrying, did we break the API controller? Because again, we can just make some very simple changes in the actual controller that we're using. Of course, we can do even more. In this morning's session, we talked about using Hadios or hyperactive links, or hypermedia as a language. In this case, what we could do is say, hey, I want to add my links in there, or my Hadios links, throw those in there per object that we're doing. So if this is the user class, I can pull those in and use them as needed, versus having to say, okay, I need to create another extension or extend my service based on the API to call in these links. Again, it gives us readily accessible information without overriding the vertical hierarchy, and also keeps things nice and isolated in a single place without bloating our code. The nice thing about this is these links, let's say we need to use them for another controller, we can just pop them over somewhere else. Or we have this API controller, we can just pull it into another controller as needed. So again, it gives us that flexibility to design things horizontally, not get stuck in that vertical line. There's a lot more information on traits in the manual. Language.oop, you know me. No, nobody? It's worth a try. Great resource there. And definitely look online, because I play with traits, work with them, and really try to find how they work for you and their good use cases. Cases where you probably don't want to use traits, don't just use traits for traits' sake. I feel like a hypocrite saying this, like, go play with them, but don't do it. You know, if you're building like a production application, don't just say, hey, I can do this with a trait, I'm going to do it with a trait for that reason. Find a good reason and say, would it be better to have this as an extended class? Would it be better to inject this through DI? Or would it be better to actually use a trait to call this in? And weigh the pros and cons of each, because just like anything, like you said, the more traits you call in, the more outside classes you call in, the more complex the application becomes, and the more work you have to do to test it. And nobody likes those applications where you have to chase down 10,000 pages to figure out what's the bug. At the same time, you will find that in certain cases, it makes more sense to call in a trait to reduce your workload. ResF, that application, again, where we're calling everything into a single class, the single class is designed to handle all that data and use all that data. That's a great example where you want to use traits. If we have an accounts class and a users class, we probably don't want to be using traits for those two to communicate, because they have their own distinct functions. So again, do you want the code to be included, or do you want it to be distinct and separate in the action and explicit in what it's doing? With that, a shameless plug. If you go up to php.com, unfortunately the magazine shut down. However, they have some free issues on there, a whole bunch of great articles by a lot of great authors. Feel free to check it out, and they're absolutely free to download. I definitely recommend getting those while you can.